3 planets sit in the same solar system, formed from the same materials, at roughly the same time. One bakes at 465 degrees Celsius under a crushing atmosphere of carbon dioxide and sulfuric acid clouds. One is a frozen desert, its atmosphere so thin that liquid water evaporates before it can pool, its surface scoured by radiation and cold. And one, the middle one, has oceans, a magnetic field, plate tectonics, life. The difference between these 3 worlds isn't random, it isn't luck, it's physics. And the same processes that destroyed Venus and stripped Mars are operating on Earth right now, held in check for the moment by a set of conditions so precisely balanced that planetary scientists sometimes refer to Earth as improbably fortunate. Understanding what went wrong on Venus and Mars is, in the most direct sense possible, understanding what Earth has to get right to stay the way it is. Venus, Earth, and Mars formed within the same few million years, from the same disk of gas and dust surrounding the young sun. They're made of similar stuff: rocky mantles, metal cores, silicate crusts. All 3 almost certainly had liquid water in their early histories. All 3 had active volcanoes releasing gases into primitive atmospheres. And yet by the time you could stand on any of them and look around, if you could stand on them, which on Venus and Mars you very much could not without dying immediately, they would look like entirely different categories of world. Venus, a volcanic hellscape under orange clouds, hot enough to melt lead, where a day lasts longer than a year, and the sun rises in the west. Mars, a rust-colored desert, its ancient river valleys and lake beds long dry, its sky a pale butterscotch, its air so thin that at the surface you'd need a pressure suit just to keep your blood from boiling, let alone to breathe. Earth, blue and green and white, wrapped in an atmosphere thick enough to breathe and thin enough to see through, with a surface temperature that allows water to exist simultaneously as ice, liquid, and vapor. The question this video is going to answer isn't just what happened to Venus and Mars, it's why those things happened. What specific mechanisms drove each planet away from habitability, and what Earth's position between these 2 cautionary tales tells us about our own planet's future. Because the lessons aren't symmetrical. Venus and Mars didn't fail in the same way. They failed in opposite directions. And Earth is balanced between those 2 failure modes. Right now, Venus failed hot. The mechanism was a runaway greenhouse effect, a self-reinforcing feedback loop between surface temperature, water vapor, and carbon dioxide that once started had no natural break. The trigger was Venus's position, about 30% closer to the Sun than Earth, receiving roughly twice the solar energy per square meter. In the early solar system, that difference may have been manageable. Computer models, including work by NASA scientist Michael Way and colleagues, suggest early Venus could have maintained a stable, temperate climate for perhaps 1 billion years or more, possibly with shallow oceans. But as the sun gradually brightened over geological time, the extra energy input began to push Venus past a critical threshold. More solar energy meant more evaporation from the surface. More water vapor, itself a powerful greenhouse gas, meant more warming. More warming meant more evaporation. The feedback loop accelerated. Temperatures climbed. Oceans, if they existed, boiled away entirely into the atmosphere. High in the upper atmosphere, ultraviolet radiation broke water molecules apart into hydrogen and oxygen. The lightweight hydrogen escaped to space. The oxygen was absorbed into surface rocks. Venus lost its water permanently and irreversibly. Without liquid water, the long-term carbon cycle the process by which carbon dioxide is drawn out of the atmosphere through weathering and ocean chemistry and returned via volcanoes, collapsed. CO2 from volcanic outgassing simply accumulated. The atmosphere thickened, temperatures rose further, the greenhouse effect intensified. Today, Venus's atmosphere is 96.5% carbon dioxide at 90 times Earth's atmospheric pressure. The surface temperature hasn't meaningfully varied in billions of years. There is no weather cycle, no seasons, no mechanism to cool down. Venus reached a stable equilibrium, just not one compatible with anything we'd recognize as a livable world. The failure mode on Venus was excess. Too much solar energy, too much greenhouse gas, too much heat. A planet that crossed a threshold and found no way back. But here's what's really interesting. Mars failed in the exact opposite direction, and understanding how requires going back to something Venus never lost, and Mars did. Mars failed cold. Not immediately, not all at once. Mars in its early history, the Noachian period, roughly 4.1 to 3.7 billion years ago, was genuinely different from the Mars we see today. Rivers carved valleys across its surface, lakes filled craters. The Jezero Basin, where Perseverance is currently exploring, held a lake roughly 45 kilometers across, fed by river deltas still visible from orbit. Mars had liquid water, a thicker atmosphere, and conditions that planetary scientists consider potentially habitable. What Mars didn't have, or couldn't sustain, was a global magnetic field. Earth's magnetic field is generated by the movement of liquid iron in its outer core, driven by the planet's internal heat. It's called the geodynamo. This field extends tens of thousands of kilometers into space, deflecting the charged particles of the solar wind, the constant stream of energetic particles flowing outward from the sun, away from Earth's atmosphere. Without it, the solar wind would gradually strip the upper atmosphere away, ion by ion over geological time. Mars lost its geodynamo. Scientists think the Martian core cooled and solidified, or at least partially solidified, relatively early in the planet's history, somewhere between 4.1 and 3.7 billion years ago. The exact timing is still debated, but the consequence was clear. Without a magnetic field, Mars was left exposed to the solar wind. Over hundreds of millions of years, the solar wind eroded Mars's atmosphere. The atmospheric pressure dropped. As it dropped, the surface temperature fell. A thinner atmosphere traps less heat. As temperatures fell, liquid water became harder to maintain. As liquid water disappeared, the carbon cycle that might have replenished the atmosphere from volcanic sources broke down. The planet entered a self-reinforcing cooling and drying cycle, the mirror image of Venus's warming cycle, and it never recovered. NASA's MAVEN spacecraft, which has been studying Mars's upper atmosphere since 2014, has directly measured the rate at which solar wind is currently stripping Martian atmosphere into space. The rate is low by human timescales, but over billions of years it was enough. Mars's atmosphere today is about 1% as dense as Earth's. Average surface temperature is around -60 degrees Celsius. Liquid water is essentially impossible at the surface under current conditions. Mars didn't burn. It bled out. Slowly, over billions of years, stripped of the atmospheric blanket it needed to stay warm and wet. And here's the part that changes everything. Because sitting between these two failure modes is Earth, and the reason Earth avoided both of them is not as simple or as guaranteed as it might seem. Venus tells us that the habitable zone has an inner edge, a distance from a star inside which the runaway greenhouse effect becomes inevitable. But it also tells us that edge is not fixed. It depends on a planet's rotation rate, its atmospheric composition, its cloud dynamics, and its history. Early Venus may have been inside the classical habitable zone and still maintain temperate conditions for hundreds of millions of years. The transition to hell was gradual, triggered by crossing thresholds, not by being in the wrong place from the start. For Earth, the Venus lesson is about feedback loops. The same feedbacks that destroyed Venus water vapor amplifying warming, CO2 accumulating without removal, operate on Earth at lower intensity. They're currently balanced by the carbon cycle and the cold trap, but they're not switched off, they're active, and the balance is maintained by conditions that can change. Mars tells us something different. It tells us that a planet can be habitable, genuinely, substantively habitable, with rivers and lakes and chemistry that might support life and lose that habitability not through dramatic catastrophe but through slow cumulative loss of the systems that maintain it. The magnetic field, the atmosphere, the water, each loss makes the next loss more likely. The planet doesn't burn. For Earth, the Mars lesson is about infrastructure, the magnetic field, plate tectonics, the carbon cycle, the cold trap. These aren't features of Earth, they're systems, active dynamic systems that maintain conditions rather than simply existing. And systems can fail. NASA's upcoming Da Vinci mission to Venus and the ongoing work of Perseverance on Mars are, in this context, not just about those planets. They're about understanding the range of outcomes for rocky worlds and calibrating where Earth sits within it. Every measurement of Venus's ancient atmosphere, every sample of Martian lakebed sediment, every model that reconstructs what these planets once were, it all feeds back into a more precise understanding of Earth's own position and trajectory. 3 planets, same origin, same solar system, same raw materials. One burned, one froze. One so far balanced. Venus crossed the threshold into runaway warming and found no way back. Mars lost the magnetic field that protected its atmosphere, bled into space over billions of years, and settled into a cold, dry, radiation-scoured desert. Earth maintained the systems, the magnetic field, the carbon cycle, the plate tectonics, the cold trap that kept it on the right side of both failure modes. But the word maintained is doing a lot of work in that sentence. These systems aren't static, they're dynamic. They require ongoing conditions to function. The sun is still brightening, Earth's core is still cooling. The carbon cycle is sensitive to perturbations. The margin between Earth's current state and the states of its neighbours is real, but it's a margin, not a guarantee. We live on the planet that got it right. So far. And the most honest thing science can do is understand exactly what getting it right means, because that understanding is the foundation of everything else. Here's the question I want to leave you with. If you had to choose one, studying Venus to understand the inner edge of habitability, or studying Mars to understand what happens when planetary systems fail quietly over time, which would you prioritize and why? Because I think the answer reveals something about how you think about risk. Whether you're more concerned about the dramatic, fast failure or the slow, incremental one, drop it in the comments. And if you want to follow this into the next natural question, what it would actually take to terraform Mars and whether the science supports the idea, that's exactly where the next video is going. See you there.